Welcome back, students. In continuation of the introduction lecture of division. So, in this lecture, we are going to discuss about how division can be performed by using Turing machine. Okay. So, we have took an example for division as 3 divided by 2. So, what will be the remainder for this? Remainder will be 1 and quotient will be 1. We know that. So how can we represent this as? So blank, then divisor, that is y, that is 2, then separated by hash, then the dividend 3 zeros. Okay. So this part we will be having quotient. This part we will be having quotient. And this part we will be having the remainder. Now how we can solve this problem? So you can see here. So the head will be starting from this 0. Now you replace this 0 as x and move to right hand side as it is. Move to right hand side. So until you are reaching hash, you have to perform the same operation without changing the input. Only the movement will be sent to the rightmost direction. Okay. So this 0 will be replaced as x and moving to the right hand side. Make this 0 as it is and move to right hand side. Then make this hash as it is and move to the right hand side. When you are seeing the next 0 after hash, first 0 after hash, this 0 will be replaced as z and you have to move to the left hand side. And you have to move to the left hand side. So for understanding purpose, I'm continuing like this. I'm continuing to writing the input like this. So now the pointer will be after this hash, the pointer will be moving to this 0. This 0 will be replaced as z and we have to move to left hand side. Why we are replacing this 0 to 0 as z means here we have replaced this 0 as x. So what is the logic behind the division? Continuous subtraction. So the meaning is now we are going to subtract these 2 zeros from these 3 zeros. Okay. So if we complete the subtraction of these 2 zeros from these 3 zeros at least one time, then it will every time when you are subtracting these 2 zeros with the set of zeros available in this side, then your quotient will be incremented by 1. So we have to perform step-by-step manner. So at a time, one input can be replaced with another input. So you see here at a time, this 0 will be replaced as x and moving to the right hand side, and this 0 will be mentioned as 0 and moving to the right hand side, and this hash will be mentioned as it is as hash and moving to the right hand side. So this hash is the separator between this part and the next part. Okay. So after going out of this hash, when you are seeing the first 0, this 0 will be replaced as z. So why we are replacing this z? Because we have crossed already 1 0 in another part. So to equalize that, so we are replacing this as z. So after replacing this 0 as z, move to the left hand side, make it as it is. Hash will be mentioned as hash and it will be move to the left hand side, and 0 will be mentioned as 0 and move to the left hand side. Now this x will be replaced as 0. Why we are replacing this x as 0 again means the operation of this particular digit has been completed, because for this 0, 1 0 has for crossing this 0, we have crossed another 0 in the another part. Okay. So the procedure for this 0 has been completed. So for continuing, for your understanding purpose, I am mentioning this. So this x will be replaced as 0 and again move to the right hand side. Now this 0's working procedure will start. So this 0 will be replaced as x and move to right hand side. Again perform the same procedure. Hash will be mentioned as hash and move to the right hand side. Now you see here z will be there, mentioned as it is. Then For this 0, we are going to cross this 0. So this 0 will be again replaced as Z and move to left hand side. Okay. So for your understanding, I'm mentioning this. Okay. So now the pointer will be here. So this 0 will be replaced as Z and we are moving to the left hand side. This Z will be mentioned as it is and move to the left hand side. Then this hash will be mentioned as it is and move to the left hand side. Now you see here, X is there. So after reaching the hash, you will be getting either X or 0. If you are getting 0 means leave as it is and move to the left hand side. If you are getting hash, when you are moving from hash to the left hand side, when you are having X means this X should be again mentioned as 0. It should be again replaced as 0 and you have to move to the left hand side. So in this procedure, so what we have to understand very carefully is, so after reaching, so why we are marking this X again to 0? Why we are marking this X again to 0? Because this digits operation is also completed, because for this 0 we have replaced this as X. The meaning is we have crossed this 0. So to equivalent for this crossing, we have crossed another 0 as Z. Okay. So this operation is also completed. So what we have did, so these two zeros are subtracted from these two zeros. Okay, from these set of zeros. So in order to ensure that after replacing this X as Z and again move to right hand side, now you will be having hash mention as it is, then move to right hand side. Then in order to mention the increment for the quotient, just replace this Z as Y and move to right hand side. Okay, and make this 0 as it is and this hash as it is. Now replace this blank with 0. Now you can see here we have subtracted these two zeros from these this set of zeros. Okay, so one subtraction has been completed. In order to ensure that we are replacing this blank with 0 and again we are moving to the left hand side. Okay, so make it as mention as it is hash, then again move to the left hand side, 0 will be there, mention as it is, then move to the left hand side, then mention Y as it is, moving to the left hand side, mention Y as it is and move to the left hand side, as it is and move to the left hand side. So again, until you are reaching the blank, you have to move to the left hand side. The meaning is one time the subtraction has been completed. After reaching this left hand side blank, again you will be moving to the right hand side. So again we have to start the procedure, because you see here in this part, in this section, we are having another input. So in order to justify those things when the input should complete, we have to continue the operation. Again, replace this 0 with X and move to right hand side. This 0 is as it is and hash. Then this Y as it is, move to the right hand side. Now you see here for this 0, we have to cross this 0 also. We have to subtract this 0. Okay. Now this 0 will be replaced as Z and you have to move to the left hand side as per the previous procedure what we continued for the first iteration. Okay. So Z will be 0 is replaced as Z and moving to left hand side. Y will be mentioned as Y and moving to left hand side. Y will be mentioned as Y and moving to the left hand side. Hash will be mentioned as hash and moving to the left hand side. 0 will be mentioned as 0 and moving to the left hand side. Now you see here this X working procedure has been completed. So replace this X with 0 and move to right hand side. Okay, and moving to right hand side. Now this zero's working procedure will start. Then replace this 0 with X and move to right hand side. You will be having hash. Then This y will be as it is, this y will be as it is and moving to the right hand side, this z will be as it is and moving to the right hand side, and clearly understand that for this zero has been crossed in this part, but no more zeros are available here. So we are having only hash. After reaching this hash, if there is no input for crossing the zero, then again move to the left hand side. Then again, now your pointer will be here. Okay. Again, so there is no input, no zeros before this hash. Okay. So already we have crossed 1 0 here. So to equivalently cross this 0 in this part, there is no zero is available. So what we have to do is again move to the left. While moving to the left hand side, replace this z with 0 and move to left hand side. This y will be mentioned as blank, replaced as blank, and move to left hand side. This y will be replaced as blank and moving to the left hand side. This hash will be replaced as blank and moving to the left hand side. This x will be replaced as blank and move to the left hand side. This 0 will be replaced as blank and move to left hand side, and this blank will be staying as it is. Now you see here, this is the left hand side part and this is the right hand side part. So you see here, this will be acting as the remainder. So remainder equal to 1 and quotient equal to 1. So this is about the division. How can we perform the division operation in Turing machine? So in the next lecture, we will discuss about how to design an automata diagram for this division operation. Thank you.